We want to use partial fraction decomposition to evaluate this integral. First, we consider this denominator, and we fully factor it down. And we set up three ratios in this case because we have three unique factors. So we go A, B, and C. Now what's going to happen is we're going to take this factored denominator and we're going to multiply every numerator by it. And that process you always basically do. Now specific things will go away at all of the locations, and we can write down the pieces that survived. We can now perform a distribution wherever applicable, and then we can continue to distribute pieces, and we can also shuffle some pieces around. We group the x squares with the x squares, we group the x's with the x's, the constant stays alone. And now what we're going to do is we're going to compare pieces with the left with pieces from the right. And we can create a system of equations. Solve this system with elimination or substitution to obtain these values for A, B, and C. And then we're going to take these A, B, and C values and we're going to bring them back up so they can replace A, B, and C, so that these three blue fractions can replace the original red fraction. So it's been decomposed. Now, quickly note that the most time-consuming part of all this was the algebra. The calculus isn't even that bad. It's the algebra that's kind of messy sometimes. So go back over here and go natural log, natural log, natural log. Don't forget your plus c, and I believe that this is what they want from us. Can this be rewritten in different ways? Sure, you can do some algebra here, but this is probably what they want from us, so this is what they get.